Statistical significance is one of those phrases that makes people either nod along pretending they get it or tune out completely, and both reactions cost small business owners money. It is not a hard idea underneath the jargon, and once it clicks, you stop shipping changes based on results that were just luck. Today I want to explain what significance actually means in plain English using a coin instead of a formula, so you can look at your own test results and know when a difference is real and when it is noise wearing a costume. I am not a statistician. I am someone who runs small businesses and got tired of being fooled by my own numbers. So I am going to skip the equations and give you the intuition that actually changes decisions. The goal is not to make you calculate a p-value by hand. It is to make you feel, in your gut, the difference between a result you can act on and one that is going to evaporate the moment you trust it. Start with a coin. Imagine I hand you a coin and claim it is rigged to land heads. You flip it 4 times and get 3 heads. Is it rigged? Obviously not. 3 out of 4 happens all the time. With a perfectly fair coin, you would see it constantly just by chance. Now flip it 400 times and get 300 heads. That is a completely different feeling. The same 75%, but at that volume, a fair coin almost never does it. Significance is just a precise way of describing that gut feeling about how surprised you should be. The real question significance answers. Every significance test is answering one specific question. If there were truly no difference between your two versions, how likely is it that pure chance alone would produce a gap at least as big as the one I am seeing? If the answer is very unlikely, you call the result significant, meaning chance is a poor explanation and a real effect is a better one. That is the whole idea. It is not proof, it is a statement about how easily luck could have faked what you are looking at.
In a sense, now I get any of is the incantation of proof. It is a statement about how easily luck could have faked what you are looking at, what a p-value actually is. The number that captures this is the p-value, and it is badly named and widely misunderstood.
A value of 5% does not mean there is a 5% chance your result is wrong. It means that if there were genuinely no difference, you would see a gap this big or bigger about 5% of the time from chance alone. Small p-value, chance is a weak explanation, so you lean toward a real effect. It is a measure of how surprising your data would be in a world where nothing was actually happening. The 95% line. People throw around 95% confidence as if it were a law of nature. It is a convention, a line somebody drew that says we will call a result significant when chance would only produce it 5% of the time or less. There is nothing sacred about 95. It is a reasonable default for balancing two risks, but for a low-stakes tweak, you might accept more uncertainty, and for a decision you cannot reverse, you might want much more. The number is a choice about how much luck you are willing to be fooled by, not a truth handed down. Why sample size drives everything? Significance depends enormously on how many people were in your test, which is exactly why small operators get burned. With a handful of conversions on each side, even a large percentage gap can easily be chance because tiny groups swing wildly. The more people flow through each version, the harder it is for luck to manufacture a big difference, and the more a real gap can separate itself from the noise. This is the coin again. 4 flips tell you almost nothing, 400 tell you a lot, and there is no shortcut around needing the volume. The difference that is real but tiny. Here is a trap that catches bigger operations. With enough traffic, almost any difference becomes statistically significant, including ones so small they do not matter. A test can prove, at high confidence, that a change lifts your conversion rate by a fraction of a percent, significant and useless. So significance is only half the question. The other half is the size of the effect, whether the difference is big enough to be worth the trouble of shipping and maintaining. Real and worthwhile are two separate checks. Inhabitability versus statistical, that gives you 2 questions to ask of every result, not one. First, is this difference likely real, or could chance easily explain it, which is statistical significance? Second, is this difference big enough to change what I do, which is practical significance? A change can be one without the other in either directions. Small operators should honestly care more about the second than they think, because a real but microscopic lift is not worth rebuilding your product for, no matter how confident the test. The multiple comparisons trap. Remember the coin. If a fair coin gives a surprising streak rarely, then flipping 20 different coins makes a surprising streak somewhere almost certain. The same thing happens when you test 20 changes or slice one result 20 ways. Some slice will look significant by pure chance, and it means nothing. If you go hunting through enough numbers, you are guaranteed to find a flattering one. This is why deciding your one metric before the test matters so much. It stops you from fishing until luck hands you a false winner. Confidence intervals tell you more. A value gives a yes or no flavor, but a confidence interval is often more honest and more useful. Instead of a single number, it gives a range the true effect probably lives in. A test might say, the real lift is somewhere between 1 and 9%. That range tells you both that the effect is probably real, since it does not include zero, and how much you still do not know, since it is wide. A range respects your uncertainty in a way a single verdict never does, and it keeps you humble about how precise your answer really is. What significance does not promise? Be clear about the boundaries. A significant result does not mean the effect is large, it does not mean it will hold forever, and it does not mean your test was designed well. Significance only speaks to the role of chance in the specific numbers you collected. A beautifully significant result from a broken or biased test is confidently wrong. The statistics sit on top of the quality of the experiment underneath, and no amount of significance can rescue a test that measured the wrong thing or split its groups unfairly. A simple rule for small tests. So here is the practical rule I actually use. If the test is small, distrust it, no matter how good the gap looks, because small samples lie easily. If the difference is tiny, ignore it even when it is significant, because it will not move your business. And if you tested many things at once, treat every exciting result as a hypothesis to confirm with a fresh test, not a conclusion. Those three habits catch the large majority of the ways a solo operator gets fooled without a single formula. Bigger effects need less data. There is a comforting flip side to the sample size problem. The larger the true difference between your two versions, the less data you need to be confident it is real. A change that doubles your conversion rate will announce itself clearly even on modest traffic, because chance struggles to fake a gap that big. It is the small subtle improvements that demand mountains of visitors to prove. So if a change is genuinely dramatic, do not agonize over tiny samples. And if a change is marginal, accept that you may simply never have the traffic to settle it. The false positive you will hit. If you run tests all year at 95% confidence, you are accepting that roughly 1 in 20 times, chance alone will hand you a significant result for a change that does nothing. That is not a flaw you can eliminate. It is the price of the whole method. The defense is memory and repetition. A genuinely real effect tends to show up again when you retest or when you watch it live, while a false positive quietly fails to reappear. Treating one surprising win as a reason to look again, rather than a settled fact, catches most of these. Regression to the mean. Here is a trap that fools people constantly. Whenever you act right after an unusually good or unusually bad stretch, the next stretch tends to drift back toward normal on its own, with or without your intervention. Change something after a terrible week and things improve, and you will credit the change when a lot of the recovery was just the week being unusually bad and the average reasserting itself. A proper test with a parallel control group is exactly what protects you from this, because the control drifts back too, and you compare against it. Decide, before launch, either how long the test runs or how many people go through each side, and do not look at the verdict until you get there. The reason is simple. The more often you check and reserve the right to stop, the more chances luck gets to briefly cross your finish line. One honest look at a predetermined end beats 100 anxious peaks every single time, and it costs you nothing but patience. Confidence is not certainty. The language around these tests oversells them, and it helps to translate as you go. 95% confident does not mean 95% certain the effect is real. It describes how often this whole method would avoid being fooled by chance if you ran it many times over, not a probability stamped onto your single result. Every individual test still lives with genuine uncertainty underneath it. The honest posture is to hold your conclusion firmly enough to act on it, but loosely enough to change your mind. The number is a long-run property of the procedure you followed, not a guarantee about the one answer sitting in front of you today. Where the details live, the fuller version of all this with the plain English walkthroughs and the small sample warnings laid out properly, lives at dataresearchanalysiscollection.com. I keep it honest there for the same reason I am careful here, because significance is precisely the tool that separates a real finding from wishful thinking, and any tool for spotting self-deception has to start by not deceiving you. No promises, no guaranteed lifts, just the idea explained until it is yours. So to recap, statistical significance asks how easily pure chance could have faked the difference you are seeing. And a small p-value means chance is a weak explanation. Sample size drives all of it, so small tests deserve deep suspicion. Always ask the second question too, whether the effect is big enough to matter, and stay alert to the trap of finding false winners when you test or slice many things. Next time, I want to talk about the North Star metric and how to pick the one number worth building your business around. I will see you in the next one.